We now discuss the solution of a problem from the section Binomial Theorem, and this problem is related to the binomial expansion. This question has appeared in the joint entrance examination main held on 27th June 2022 in the first shift. The given question is, if the coefficient of x to the power of 10 in the binomial expansion of root x by 5 to the power of 1 by 4 plus root 5 by x to the power of 1 by 3 whole to the power of 60 is 5 power k multiplied by L, where L, k are natural numbers and L is co-prime to 5, then k is equal to. We are given root x by 5 to the power of 1 by 4 plus root 5 by x to the power of 1 by 3 whole to the power of 60. And we have to expand this in the binomial expansion, and we have to find the coefficient of x to the power of 10 in this binomial expansion, and it is given that coefficient of x to the power of 10 in this binomial expansion as 5 to the power of k multiplied by L, where L and k are natural numbers, and it is given L is co-prime to 5, required to find the value of k. So that is our given question. Now, we now discuss the solution of the problem in detail. So we take the binomial expansion and write down its general term. The general term is given by TR plus 1 is equal to n is 60 CR multiplied by root x by 5 to the power of 1 by 4 to the power of 60 minus r, that is same as x to the power of 1 by 2 by 5 to the power of 1 by 4 whole to the power of 60 minus r multiplied by root 5 by x to the power of 1 by 3 whole power r. It is same as 5 to the power of 1 by 2 by x to the power of 1 by 3 whole power r, where r varies from 0 to 60. Now let us collect the powers of x. This will be equal to 60 CR into x to the power of 60 minus r by 2 into, from here it is 1 by x to the power of 1 by 3 to the power of r, that will be x to the power of minus r by 3. So that minus r by 3 is here into 5 to the power of r by 2 from here, from the second term. From the first one, it is 5 to the power of minus 60 minus r by 4. So this is r by 2 minus 60 minus r by 4. Take the LCM in the first part. If you take the LCM, it is 6, and it says 360s are 180 minus 3r minus 2r. That is 180 minus 5r by 6. X to the power of. So that will be equal to 60 CR x to the power of 180 minus 5r by 6. And from here, in the powers, the LCM is 4. Then you will get 2r minus 60 plus r. That will be 3r minus 60 by 4. So that is TR plus 1 is given here. So that is 60 CR x to the power of 180 minus 5r by 6 multiplied by 5 to the power of 3r minus 60 by 4. To obtain the coefficient of x to the power of 10, take the exponent of x and equate it to 10. That is 180 minus 5r by 6 is equal to 10. Cross multiply and simplify, we will get 5r is equal to 120 and r is equal to 24. Now, what is the coefficient of x to the power of 10 now? Now, that will be given as from here 60 CR multiplied by 5 to the power of 3R minus 60 by 4 where r is 24. Substitute r is equal to 24 in this. 60C24 into 5 to the power of 24. 24 3s are, 3r means 24 3s are 72 minus 60, that is 12 by 4, that is 3. So 60C24 into 5 cube. 60C24, that is NCR is equal to n factorial by r factorial into n minus r factorial, and that is equal to 60 factorial by 24 factorial into 36 factorial into 5 cube. Now, from this 60 factorial by 24 factorial by 36 factorial, now extract all powers of 5, and multiply with 5 cube. Then write it as 5 to the power of k into L, where k and L are natural numbers, and L is relatively prime to 5. That we do in the next slide. So we have the coefficient of x to the power of 10 as 60 factorial by 24 factorial into 36 factorial into 5 cube. We have to extract all factors, all factors of, the factors of 60 factorial. That means the all powers of 5. So how many times the 5 is a factor for 60 factorial? That means we want to find the exponent of 5 in 60 factorial. That means x to the power of a divides 60, and that is 5 to the power of a divides 60 factorial, and 5 to the power of a plus 1 does not divide 60 factorial, and that is a is an exponent of 5. So in 60 factorial. And to do this one, we recall a result from number theory, that is the exponent of a prime in a factorial. And we take the prime as p and the factorial as n factorial. So if p is a prime number, then the exponent of p in n factorial is given by the bracket n by p plus bracket n by p square plus bracket n by p cube plus so on and so forth, where bracket n by p is the greatest integer less than or equal to n by p, where bracket is the greatest integer function. Now in our case, n is 60 and p is 5 now. Now p is 5. So it will be bracket 60 by 5 plus bracket 60 by 5 square plus bracket 60 by 5 cube. 60 by 5, 5 7s are 12s are 60. Okay, it is 12. 60 by 50. 60 by 25. So 25 2s are. So let's see, 12 plus 2, and 60 by 125 is 0. That is total is 14. Now exponent of 5 in 24 factorial. This is bracket 24 by 5 plus bracket 24 by 5 square. And 24 by 5 is 5 4s are 20, 5 5s are 25, it is 4. 24 by 25, it is 0. It is 4 plus 0 is 4. And the exponent of 5 in 36 factorial is 36 by 5, that is 5 7s are 30, plus 36 by 5 square, 36 by 25, that is 1, plus 36 by 5 cube, it is 0. 7 plus 1 plus 0, that is 8. So that means from 60 factorial, we extract 5 to the power of 14 as the factor. In the remaining part, that is the remaining part of 60 factorial, after dividing by 5 to the power of 14, what you remain is relatively prime to 5. That means it doesn't have a factor, 5 as factor. So also for 24 factorial, we extract 5 to the power of 4. From 36 factorial, it is 5 to the power of 8. So we'll get the coefficient of x to the power of 10 in this is given by 5 to the power of 14 from 60 factorial, and 5 to the power of 4 from 24 factorial, 5 to the power of 8 from 36 factorial, and 5 cube is already there. And now when you extract these factors, the remaining part is L. And 5 doesn't divide L. That means L and 5 are relatively prime. That is, L is co-prime to 5. So thus we get 5 to the power of 17 by 5 to the power of 12. That is 5 to the power of 5 into L, and where L is co-prime to 5, and it is given to us in the question 5 to the power of k into L, and required to find what is the value of k. So from this, what you get is k is equal to 5. So k is equal to 5 is the answer for this question, and that is the detailed discussion of the solution of the problem from this section binomial theorem. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.